Hello students, this is SANTOSHSIR from Parth Tank Mathematics Institute, Ahmedabad. In this video, I'll take you through the solutions of the mathematics part of NTA test paper number 4. Parth Tank Institute is presenting to you the solutions of the mathematics part of all the NTA test papers. Please do follow them. The first question. The relation less than in the set of natural numbers is, that is, can we say that this relationship x is related to y if x less than y is symmetric, transitive, reflexive, equivalence relation, etc. Now if you see, is x related to x, this would mean that x should be less than x, which is not true, so it is not reflexive. Is it symmetric? X related to y implies y related to x, that is, it should mean that x less than y should imply y less than x, which is also not true, so it is not even symmetric. What about transitive? X related to y and y related to z should imply x related to z. Now this means x less than y, y less than z. If x is less than y and if y is less than z, definitely x is less than z, right? Therefore, it is transitive. This is the condition for transitive. So the relation is only transitive, not symmetric, not reflexive, and therefore also not an equivalence relation. So the option B, only transitive, is the right answer. Question number 2. If I1 is an definite integral and I2 is another integral, then I1 is to I2 is equal to. Now these two are fairly simple integrals. We use some properties of definite integrals and these are done in a jiffy. Let's see. I1 is integral 0 to pi x sin x by 1 plus cos squared x dx. Now we know that integral f of x dx from 0 to a is equal to integral f of a minus x dx 0 to a. So in this case, using this rule, 0, a is pi, I1 can also be written as integral, put a minus x in the place of x, that is pi minus x in the place of x, pi minus x sine of pi minus x by 1 plus cos squared pi minus x dx. Now if you see, this becomes, the limits are unchanged, this becomes pi sine x, because sine pi minus x is just sine x, second quadrant sine is positive, cos is negative, but cos squared becomes positive. So in the numerator we have another term, pi times sine x minus x times sine x dx upon 1 plus cos squared x 0 to pi. Now if you add these two equations, you get 2I1 is nothing but the x sin x and x sin x part get cancelled, and I have 0 to pi sin x by 1 plus cos squared x dx. Alright. Now how to evaluate this? Take cos x as u. So du is minus sin x dx. And the limits, x is 0 mean u is 1 and x is pi mean u is minus 1. Therefore this integral 2I1 is equal to integral 1 to minus 1 pi sin x dx is minus du divided by 1 plus cos squared x is 1 plus u squared, right? Now you can change the limits and cancel that negative sign. So pi times du upon 1 plus u squared, and du upon 1 plus u squared is nothing but tan inverse of u from minus 1 to 1. Now what is tan inverse of 1? Pi by 4 minus tan inverse of minus 1 is minus pi by 4, right? So this becomes pi squared upon 2, but this is equal to 2i. Alright. Therefore I will be pi squared upon 4. I1 will be pi squared upon 4. Let me write it down here. I1 is pi squared upon 4. Okay. Let us go to I2. I2 is integral 0 to pi x sine power 4x dx. Now using the same rule, I can write I2 is also integral pi minus x sine power 4 of pi minus x dx, same limit 0 to pi, and then you add them both, you get 2I2 is only pi sine power 4 x, sine of pi minus x is sine x dx 0 to pi. Now there is also another rule, right? If f of a is equal to f of x is equal to f of 2a minus x, then integral 0 to 2a f of x dx if can be written as 2 times integral 0 to a f of x dx. So in this case, you can see, take this as 2a. So 2a is pi. So sine pi minus x should be equal to sine x, right? We have sine pi minus x is equal to sine x. Therefore, this whole integral can be written as 2I2 is pi times, and I can take a 2 out, and integral 0 to pi by 2, if pi is 2a, a is pi by 2, sine power 4x dx. Now these have simple rules, right? If sine power nx dx from 0 to pi by 2, when n is even, can be written as starting from n minus 1, n minus 3, you go on up to 1, and the denominator is starting from n, you go to n minus 2 and so on up to 2, and you put a pi by 2. So integral 0 to pi by 2 sine power 4x dx is going to be 3 into 1, stop there, by 4 into 2, stop there, into pi by 2. So the answer is 3 pi upon 16. So we have 2I2 is 2 pi into 3 pi upon 16, which will give us 2 and 2 are gone, or I2 is 3 pi squared upon 16. Now we need the ratio I1 is to I2. We found I1 is pi squared upon 4 by I2 is 3 pi squared upon 16. Now this becomes pi squared by 4 into 16 by 3 pi squared. Pi squared is gone, this is gone. So 4 upon 3. So I1 is to I2 is 4 upon 3, which is option C, 4 upon 3. Very simple problem. We are using the property f of x dx integral 0 to a is integral 0 to f of a minus x dx, which eliminates the x from here, right? And then using a simple substitution technique, you get I1 is pi squared by 4. Here use the same technique, bring it to 0 to pi by 2, and then use this formula. Now if it is an odd number here, just for the sake of completeness, the same formula holds, but it will be only, this pi by 2 will be replaced by 1. It will only be the numbers here, no pi by 2. Okay. Now let us move on to question number 3. Two sides of a triangle are given by the roots of the equation x squared minus 2 root 3x plus 2 is 0. And the angle between the sides is pi by 3. So if I were to draw a triangle, now there is, let's say this side is A, this is B and C, and this angle is pi by 3, and they say this A and B are roots of this equation. Okay, so find the roots of the equation, and then you are set to find, using these two sides and this angle, you can find this, through which you can find the perimeter, right? Simple. So the roots of the equation, x should be plus 2 root 3 plus or minus square root of b square, which is 12, minus 4ac is 8 upon 2. This becomes 2 root 3 plus or minus 12 minus 8 is 4, so square root of 4 is 2 upon 2. This becomes root 3 plus 1 or root 3 minus 1. So you can take any of them as A and this can be B. How to find C? We have the nice triangle equation. A squared, the cosine formula I mean, minus 2AB cos C. Now this vertex should be C, this vertex should be A and this vertex should be B in terms of the naming conventions of triangles, right? The angle opposite, the side opposite to angle A is A, side opposite to angle C is C, etc. So substitute this, substitute the given value. So this is root 3 plus 1 the whole square plus root 3 minus 1 the whole square minus 2 root 3 plus 1 root 3 minus 1 into cos pi by 3. So this becomes 3 plus 1 plus 2 root 3 plus 3 plus 1 minus 2 root 3, and then here I have 3 minus 1, right? A squared minus B squared. So that becomes 2 into 3 minus 6 plus 2. The whole term here. Sorry. This would be, let me just quickly correct this. What I am saying is this should be 2 into root 3 minus 1, root 3 square minus 1 square is 3 minus 1 into 1 by 2. Okay, so this term is 2. So here I have, cancel these 2, 8 and minus 2 or 6. So C squared is 6 and C therefore is root 6. Okay. So I have the three sides, root 3 plus 1, root 3 minus 1 and root 6. So the perimeter is root 3 plus 1 plus root 3 minus 1 plus root 6. This becomes 2 root 3 plus root 6. So the answer is 2 root 3 plus root 6, option C. Okay, very simple. Solve the quadratic equation and use the law of cosines to get the third side. Question number 4. At an election, a voter may vote for any number of candidates not greater than the number to be elected. Okay, the number of candidates is 10 and 4 are to be elected. If a voter votes for at least one candidate, then the number of ways in which he can vote. Now, the number of votes, let us say, the voter can vote for one person, for one candidate, or for two candidates, or these are candidates for one candidate, two candidates, or three candidates, or four candidates. And that is the maximum because there are only 4 to be elected. So the maximum number that he can vote is only 4. And since I have said at least one candidate, we have 1 or greater than 1, which is 1 candidate, 2 candidates, 3 or 4. So in how many ways can he vote for one candidate? From 10 candidates he has to choose 1, or he has to choose 2 from 10, or he has to choose 3 from 10, or he has to choose 4 from 10. Evaluate this quickly. This is 10. This would be 10 into 9 by 2. This would be 10 into 9 into 8 by 3 into 2 into 1. This would be 10 into 9 into 8 into 7 by 4, 3, 2, 1. So this is 5. 10 plus 45. And here I have 3 and 4. So this becomes 120. And here I have 3, so 210. So 330, 340, 385 ways in which he can choose. So there are 385 ways in which he can vote. Okay, very simple permutations and combinations problem. Let us move on to question number 5. If m is any natural number, then the value of the integral, this whole integral, x to the power 3m, x to the power 2m, x to the power m, and this, where c is an arbitrary constant, s. This looks a little bit scary with the power 1 by m and all, but we'll try to make the whole thing here a derivative of some term here. To do that, I'm going to multiply and divide the second term by x to the power m. Okay, so x to the power m by x to the power m of all these things. The whole raised to 1 by m dx. Now the numerator, and this x to the power m to the power 1 by m becomes just x. Let us use that to divide these three terms. What I mean is, this x to the power m to the power 1 by m is just x. Put it here and see what happens here within. This becomes 2x to the power 3m, 3x to the power 2m, 6x to the power m. Correct? Okay. Now you take, okay, sorry, let's simplify this one more step so that things are a little more clear for us. 2m minus 1 plus x to the power m minus 1 into the same term here, 2x to the power 3m, 3x to the power 2m, 6x to the power m dx. Now if I take u as 2x to the power 3m plus 3x to the power 2m plus 6x to the power m, then du, when I differentiate this, I get 2 into 3m x raised to the power 3m minus 1 plus 3 into 2m x raised to the power 2m minus 1 plus 6 into m into x raised to m minus 1. So if I take 6m constant and to the other side, because here I have 6m, 6m and 6m, I can write du by 6m is x raised to 3m minus 1 plus x raised to 2m minus 1, excuse me, I missed the dx here, x raised to m minus 1 dx. So you see, this whole term became du by 6m, and this term is just u to the power 1 by m. So the integral becomes u to the power 1 by m du by 6m. Now keep the 1 by 6m constant, and u to the power 1 by m is going to become u to the power 1 by m plus 1 by 1 by m plus 1. Now this is nothing but 1 by 6m into this whole term is nothing but m plus 1 by m, and when it goes up it becomes m by m plus 1, and then I have u is 2x to the power 3m plus 3x to the power 2m plus x to the power m, the whole power again m plus 1 by n. Cancel this. So the answer is 1 by 6 times m plus 1, 2x to the power 3m plus 3x to the power 2m plus x to the power m, the whole raised to n plus 1 by n. And this is option A. 1 by 6 m plus 1, 2x to the power 3m and all that. Only this term has a 6m plus 1, right? And this is the power, this is the 1 by 1 plus m, if you want to keep it the same way. So the answer is option A. Very simple, multiply and divide by x power n, and using that you get u du form. Let us go to question number 6. If 2 into y minus a is the harmonic mean between y minus x and y minus z, then x minus a, y minus a and z minus a are in AP, GP or HP. So they have given us that y minus x and then this 2 times y minus a and y minus z are in harmonic progression. Okay. Now this means that 1 by y minus x, 1 by 2y minus a and 1 by y minus z are in AP. Correct? So what does this mean? This means that this term is the average of these two terms. So 1 by 2 times y minus a is nothing but 1 by y minus x plus 1 by y minus z upon 2. Correct? Now this 2 and this 2 can be dropped, and let us do some simplification in order to bring in our x minus a, y minus a and z minus a. To do that, here I am going to subtract a and add a, and the adding a I put as a minus a here like this. So you see there is a minus a and a plus a. So eventually it is 1 by y minus x. And the same way here I do y minus a minus z minus a. Now you see we have x minus a, y minus a, z minus a everywhere. Let us call x minus a as some capital X, y minus a as some capital Y, and z minus a as some capital Z. Okay. So this equation can be written as 1 by capital Y is 1 by capital Y minus x plus 1 by capital Y minus z. This is just for the sake of simplification because we need information about only these three terms. So let us get the relationship between all these three. Normal algebra from here. So I have, let me write it again, 1 by y is 1 by y minus x plus 1 by y minus z. So this LCM on the right hand side becomes y minus z plus y minus x by y minus x into y minus z. So cross multiplication, y squared minus yz minus xy plus xz becomes equal to, here if you see there is again y squared minus yz plus y squared minus xy. So cancel all the terms, there is a minus yz minus xy minus yz minus xy, and one y squared and y squared also is gone. So the terms that are left are y squared is xz, and since we know y squared is nothing but y minus a squared, x is x minus a and z is z minus a. We see that x minus a, z minus a and y are in GP because the middle term square is the product of the other two terms, right? X minus a, y minus a and z minus a. If they are in GP, this square will be the product of these two terms. So the answer is they are in a geometric progression, option B. Let us move on to question number 7. The number of quadratic equations that are unchanged by squaring their roots is, that is, if you have a certain quadratic equation, let us say ax squared plus bx plus c is 0, they say that, and if it has roots alpha and beta, if you square these roots alpha squared and beta squared, will the equation remain the same? If so, how many such equations can be formed? That is, ax squared plus bx plus c is the solution of alpha and beta and also of alpha squared and beta squared. Interesting question. So let us see. What would this mean? From the first equation, let us say from the first and let us say to the second. From the first equation we can say alpha plus beta should be minus b by a, and alpha beta should be c by a. Now from here I can say from the second equation, this is from 1, this is from 2. From the second equation, alpha squared plus beta squared also should be minus b by a, and alpha squared into beta squared should also be c by a. So it is from these two that we will try to obtain the solutions. First, notice these two, right? Therefore I have alpha squared beta squared is equal to alpha beta, which implies that alpha squared beta squared minus alpha beta is 0, or alpha beta into alpha beta minus 1 is 0. This implies that alpha beta is 0 or alpha beta is 1. So we will work on these two conditions now. So first thing is case 1, alpha beta is 0. Now this implies that one of the roots is 0. For the sake of convenience, let us say alpha is 0 and beta is some value. And now what is the other condition that we have? Now if alpha is 0, if I substitute that in any of these equations, I have beta is in this equation I get beta is minus b by a, and from this equation I get beta squared is also minus b by a. This implies that beta is also equal to beta squared. That means beta squared minus beta is 0, or beta into beta minus 1 is 0. Beta is either 0 or 1. So therefore alpha can be 0, beta can be 0, alpha can be 0, beta can be 1. These are two solutions for which that equation will remain the same even if you square, obviously, right? If these roots are 0, then the equation is x squared is equal to 0. The square of the roots are the same. Here also the roots and the square is the same. Okay. Based on this, you might have already guessed that 1 comma 1 should be a solution, because so that when you square, they won't change at all. Anyway, let's work that out. The second case is, we said alpha beta is equal to 1, right? Alpha beta is 1. So in this case, we know that alpha or beta, let us say, should be 1 upon alpha. So the first equation says alpha plus 1 by alpha is minus b by a. And the second equation says alpha squared plus 1 by alpha squared is also minus b by a. Right? So this, what does this become? This becomes alpha plus 1 by alpha is equal to alpha squared plus 1 by alpha squared. Therefore, alpha squared plus 1 by alpha squared minus these two, minus alpha minus 1 by alpha is 0. Let us do the LCM quickly and consider only the numerators. I have alpha power 4 plus 1 minus alpha cube, right, minus alpha cube, and minus alpha is 0, or alpha power 4 minus alpha cube minus alpha plus 1 is 0. Alpha is 1 is the root of this equation, if you see, right? If I put 1 in here, I get alpha, this whole equation becomes 0. So alpha is equal to 1 is a solution. And then how to find the other solution? Synthetic division I suggest. So it is 1 minus 1, 0 minus 1 and 1. And if 1 is a root, this is 0, 1. This 1 becomes 0, and then 0 becomes 0, and 0 becomes minus 1, and 1 and minus 1 is minus 1 and 0. So this equation is nothing but alpha cube minus 1 is equal to 0. Now alpha cube minus 1 is equal to 0 has 3 roots. Alpha is 1, omega and omega squared. 1 is already a root, so the other root shall be omega or omega squared. Now you see, if I take alpha as 1, then I will get beta as 1. If I take alpha as omega, then beta will be 1 by omega, which is omega squared. If I take alpha as omega squared, beta will be 1 by omega squared, which is omega. Therefore, the only two possibilities are 1 comma 1 for alpha and beta, and omega comma omega squared for alpha and beta. Alright? So there are only 4 solutions. Here I have 0 and 1, 0 and 0. So the others are 1 and 0, omega and omega squared. So for these 4 roots, the square of the roots and the roots themselves will have the identical equation. 3 of these 4 cases are trivial, but the last case is interesting because omega squared is omega, omega squared will be omega, this squared will be omega, and this squared will become, this squared is omega squared and this squared is omega. That is, even if you square, the roots remain the same, is what I am trying to say. Therefore the answer is, there are 4 such equations. Okay. Moving on to question number 8. If 1 plus 3p by 3, 1 minus p by 4, 1 minus 2p by 2 are probabilities of mutually exclusive events of a random experiment, then the range of p is. So first of all, how to find the range of p? We know each probability should be greater than 0 but less than 1. That is one condition. And then the sum of all the probabilities should be less than 1. Okay. So let us take each probability. First probability, 1 plus 3p by 3 should be greater than 0 or less than 1. It can be greater than or equal to, can be, okay. So this would give me, for the 1 plus 3p by 3 greater than or equal to 0, I would get p should be greater than or equal to minus 1 by 3. Now 1 plus 3p less than or equal to by 3 less than or equal to 1, I would get p should be less than or equal to 3 ones are 3 minus 1 2, so 2 by 3. Okay. Now the second one, 1 minus p by 4 also should satisfy similar conditions. Now 1 minus p by 4 greater than or equal to 0 would imply p should be less than or equal to 1, right? It is a minus p, so 4 minus p will be greater than minus 1, so p will be less than 1. The same way, 1 minus p by 4 less than or equal to 1 would imply 4 minus 1 is 3. So P should be greater than or equal to minus 3. Then the third probability is 0, 1 minus 2P by 2 less than or equal to 1. So this would give me 1 minus 2P by 2 should be, if I say it is greater than or equal to 0, this would imply that 2 is 0 and P greater minus P greater than minus 1 by 2, or P should be less than or equal to 1 by 2. The same way I get 1 minus 2P by 2 less than or equal to 1. So 2 here and 1, 1. So P should be greater than minus 1 by 2. Right? I hope all these things are quite clear. Very good. So we got conditions for the individual probabilities. P greater than minus 1 by 3, P greater than minus 3, P greater than minus 1 by 2. And then we have P also should be less than 2 by 3, less than 1 or less than 1 by 2. So from these three, the lowest limit is 1 by 2, of course. Now, let us consider the total probability also should be less than 1. So that is 1 plus 3P by 3 plus 1 minus P by 4 and 1 minus 2P by 2 should be less than or equal to 1. So this, the LCM is 12, of course. So 4 plus 12P plus 3 minus 3P plus 6 minus 12P should be less than or equal to 1. So I have 12P is gone. So 4 plus 3 plus 6 is 13 minus 3P should be less than or equal to 12, or I have 12, 13 minus 12 should be less than or equal to 3P, or P should be greater than or equal to 1 by 3. Okay. So now I have several such conditions. What are they? I have got P should be greater than or equal to 1 by 3. Then from the previous cases, P greater than minus 1 by 3. And here I have P greater than minus 3. And finally P greater than minus 1 by 2. Okay. And for the other side, I have P less than or equal to 2 by 3, P less than or equal to 1, and P less than or equal to 1 by 2. So I should choose the greatest among these and the smallest among these, right? If it has to be, it is like on the number line, minus 3 may be somewhere here, minus 1 by 2 will be here, minus 1 by 3 will be here, and 1 by 3 would be somewhere here. So P has to be greater than all of these, right? P has to be, so only this region is allowed. The same way here I have P less than or equal to 1 could be somewhere here, and 2 by 3 could be somewhere here, and 1 by 2 could be somewhere here. It has to be less than all these. Only this region is the allowed region, which is 1 by 3 to 1 by 2. So P should be greater than or equal to 1 by 3 and less than or equal to 1 by 2. Let us see. 1 by 3 and 1 by 2 we have in option A. Very simple, just the inequalities. Each probability should be greater than 0 but less than 1, and the total probability should be less than or equal to 1. Question number 9. F of x is equal to secant of log of x plus square root of 1 minus 1 plus x squared. Is it an odd or even function, or what is it? How do we find? Calculate f of minus x. So we put secant log of minus x plus square root of 1 plus minus x the whole square. Right? This becomes 1 plus x squared. Now take this term as a and this term as b, and let us try to rationalize this. That is, I am going to do this b minus a, right? It can be said b minus a can be written as b squared minus a squared by b plus a. That is, root of 1 plus x squared minus x, this term here, can be written as square of the first term, 1 plus x squared minus a squared, this term squared, upon the sum of these two terms. So 1 plus x squared plus x, right? So this becomes 1 here, 1 upon x plus root of 1 plus x squared. So this whole bracket here is nothing but f of minus x is secant of log of 1 upon x plus root of 1 plus x squared. This is nothing but secant log of x plus root of 1 plus x squared, the whole raised to minus 1, and this minus can come here, secant of minus log x plus root of 1 plus x squared. And now of course we know that secant is an even function, so secant of minus something becomes secant of plus that number. So this is equal to f of x. So we have f of minus x is equal to f of x, so it is an even function. So the answer is B, even function. Moving on to question number 10. The equation of the bisectors of the angles between the lines represented by the equation 2x plus 2 the whole square plus 3x plus 2 into y minus 2 minus 2y minus 2 the whole square is equal to 0 is which one? Okay. Now first let us find the two lines from this, and then we'll go for the equation of the angle bisector. Okay. The two lines, how can we do that? See, it's the same term, so let us factorize them accordingly. The whole thing can be factorized as x plus 2 and y minus 2, and you have to find some factors x plus 2 and y minus 2. Okay, that is 2 and 2, and this is plus 3, so it has to be 2 times this and 2 times this, minus 1 times this and plus 2 times this, right? You can factorize it otherwise also. You take x plus 2 common from here, and then or split this as 2 times x plus 2y minus 2 plus x plus 2y minus 2, however you want. So this becomes 2x minus y, and 2x plus 2 is 4, 2 times 2 is 4, plus 2 is 6. And then here I have x plus 2y, and then 2 minus 4 is minus 2. So these are the two lines, 2x minus y plus 6 and x plus 2y minus 2. Both are equal to 0. Now the angle bisector, if you have two lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 is equal to 0, then you know the angle bisectors are given by a1x plus b1y plus c1 by square root of a1 squared plus b1 squared should be equal to plus or minus a2x plus b2y plus c2 by square root of a2 squared plus b2 squared. This basically means that any point on the angle bisector is equidistant from both the lines, right, using that property. Okay. So now we have this equation and we have this equation. Let us write this here. So this becomes 2x minus y plus 6 by square root of 2 square plus 1 is root 5 is plus or minus x plus 2y minus 2 by square root of 1 plus 4, which is also 5. So this is cancelled. So I have sum of these two and the difference of these two equal to 0. Basically, the first equation, if I take the positive sign, will be 2x minus y plus 6 is equal to x plus 2y minus 2, right? So this equation will be x minus 3y plus 8 is 0. Now the second equation would be 2x minus y plus 6 is equal to minus of x plus 2y minus 2. Now minus of x is 3x, minus of 2y coming to the side becomes plus y, plus 2 coming this side becomes plus 4 is 0. Now the final answer is, you have to give it in the pair of straight lines form. So multiply this and this. These are the two angle bisectors, remember. When you multiply, I get 3x squared. What about the xy term? Xy minus 9xy is minus 8xy What about the y squared term? Minus 3y squared. X term, x into 4, 4x plus 8 into 3 is 24x, so 28x. And the y term, minus 3y into 4, minus 12x, minus 12y plus 8y, so minus 4y, and then 8 4s are 32. So this is the equation. 3x squared minus 8xy minus 3y squared plus 28x minus 4y plus 32. And where is that? All the numbers are very similar, so be very careful. 3x squared minus 8xy minus 3y squared. So this one or this one, okay, let us continue. 28x plus 28x minus 4y plus 32. So option C. 10 is option C. Question number 11. Let phi of x be the inverse function of f of x. So what they have given is phi of x is the inverse function, right? So if you take f of phi of x, you would get x basically. Okay. And f dash of x is equal to 1 by 1 plus x to the power 5. Then the derivative of phi of x is equal to. Now we have this equation which is given because they have said phi is the inverse function of f, right? What we have written is just f of f inverse is equal to x basically. Okay. So f of phi of x is equal to x. Now if I have to differentiate this on both sides with respect to x, I get f dash of phi of x into the derivative of phi of x by dx is equal to 1, or d phi of x by dx, which is what we need, is equal to 1 by f dash of phi x. Now we know f dash of x is 1 by 1 plus x power 5. So f dash of phi of x is 1 by 1 plus phi of x to the power 5. So this becomes 1 plus phi of x to the power 5, which is option C. So 11 is option C, 1 plus phi of x to the power 5. Very simple. Definition of inverse function, right? And differentiate it. Question number 12. The possible values of scalar k such that the matrix A inverse is equal to minus ki is singular, where A is equal to this given matrix R. Okay. Now A inverse minus ki is equal to is singular means that determinant of A inverse minus k into the identity matrix is 0. Singular, right? Now to find the A inverse and then substitute this and then find the determinant. Now this can be simplified if we see quickly that determinant of A here is 1 into 0, 0 into 0, 2 into determinant of A is just minus 4. Okay, so it is not 0. So A is not a singular matrix. So A inverse exists, of course, and therefore I can multiply both sides by determinant A. Right? Now this will remain 0. Now product of determinants is equal to the determinant of the product. So this becomes I minus k A, right? A inverse is I, A into k into I is ka is 0. Now of course still k into k multiplied by A would have too many non-zero elements, so I still do one small modification, take k common out of the whole thing. So if I take k common, it becomes like k times I by k minus A is 0. The determinant of k times I by k minus A is 0. Now k can be dropped. K when it comes out of the determinant becomes like k to the power n, k cube basically, and k can be taken out. So what I have is determinant of A minus I by k is 0. I am just changing the sign, which is nothing much. Let us call 1 by k as some m. So I have a nice form, A minus mi is 0. Let us try to find what this would give me. A minus mi. Now A is 102, 021 and 100 minus M times I is M00, 0M0, 00M, or 1 minus M, 0, 2, 0, 2 minus M, 1, 1, 0 minus M. This determinant should be equal to 0. Let us evaluate this determinant carefully. So 1 minus M times 2 minus M into minus M, right? This term is 0 and the second term is 0, plus 2 into, this is 0, minus of 2 minus M. So this becomes 3 plus, this is a mistake. This becomes 1 into 2, 2, M into M is M squared, and minus 2M minus M is minus 3M into minus M, and then I have here minus 2 times 2 is minus 4, and plus M times 2 is plus 2M is 0. Simplifying further, minus M cubed plus 3M squared minus 2M minus 4 plus 2M is 0, or since these two cancel each other, M cubed minus 3M squared plus 4 is 0, right? M cubed plus 3M squared minus 3M squared plus 4 is 0. Now what will be the roots of this equation? M is equal to 1, no, M is minus 1, yeah. So M is minus 1 is the root of this equation by substitution. Minus 1 minus 3 plus 4 is 0. Okay. Now to simplify this equation, you put M is minus 1 is the root, right? So I do the synthetic division again. 1 minus 3, 0 and 4, and put minus 1. So this becomes 1 minus 1. So minus 4 becomes plus 4. So this is 4 and minus 4 becomes 0. So the equation I have again is M squared minus 4M plus 4 is 0. Now this is nothing but M minus 2 the whole square is 0, or M is equal to 2. So the two values of M are M is minus 1 and M is 2. And we know K is 1 by M. Therefore this would be, K would be minus 1. There is a root minus 1 is minus 1 and 1 by 2. So 1 by 2 and minus 1 are the solutions to this problem. 1 by 2 and minus 1 is option B. So 12 is option B. Moving on to question number 13. The negation of P and Q implies minus R is. Now we know that the negation of P, that is negation of P or Q, implies not R is. Now we know that the negation of P or Q, P and Q should be negation of P or negation of Q, right? De Morgan's law. So the first step, this would become negation of P or negation of Q implies negation R, right? And then we also know that negation of P implies Q is nothing but P and not of Q, right? So using this here, these are identities. We are using these to simplify, right? Do not get confused. So here, consider this as P and this as Q. So this becomes negation of P, or negation of Q implies not R becomes Q and not of not R, which is not P or Q and R. So not P and Q and R is not P or Q and R, option D. So question number 13, option D. Remember the identities, these are simple to solve. 14. If, let me rewrite for clarity, 1 plus sine theta plus sine squared theta plus sine cube theta up to infinity is 4 plus 2 root 3, and theta is between 0 and pi. Then what are the values of theta? Now this is a geometric progression, and since sine theta is always going to be less than or equal to 1, we can use the infinite series representation. So the sum to infinity for a series with a and common ratio r, first term a, common ratio r, sum to infinity is a by 1 minus r. Here a is 1 and r is sine theta. So my sum to infinity is 1 upon 1 minus sine theta, which is given to be 4 plus 2 root 3. Okay. Now to simplify this, let us do the componendo dividendo. I need sine theta in the numerator. So if I subtract numerator and the denominator, I get sine theta, right? So let this be a by b. What I am going to do is, if a by b is equal to c by d, it is also possible to write b a minus b by a is c minus d by c. Correct? A minus b by a is c minus d by c. Or if you do not want all this, just go ahead and multiply and see what you get. Okay. So this way it becomes 1 minus sine theta by 1 a and b, right? And c minus d is, c is 4 minus this, so this becomes 3 plus 2 root 3 upon c is 4 plus 2 root 3. So basically I have sine theta equals this term. This side is sine theta. So now this has to be simplified a little bit. So let us see, sine theta is 3 plus 2 root 3 by 3 by 4 plus 2 root 3. Now rationalizing the denominator by multiplying by the conjugate of the irrational number, I get the denominator is 16 minus 12, and the numerator becomes 12, and we are multiplying it carefully, minus 12 and then plus 8 and minus 6, so that is plus 2 root 3, or this becomes 2 root 3 upon 4, which is root 3 by 2. All the simplification to get a nice root 3 by 2. Now in 0 to pi, we know there are two angles that satisfy this, which is pi by 3 and 2 pi by 3. Both in the first and the second quadrant, sine is positive, and 60 and 120 are both have sine values root 3 by 2. Therefore the answer is pi by 3 or 2 pi by 3, option D. So question 14, option D is the right answer. Moving on to question 15. The function f of x, which is 1 minus sin x plus cos x by 1 plus sin x plus cos x, is not defined at x is equal to pi. The value of f of pi, so that f of x is continuous at x is equal to pi, is, if it has to be continuous, then the limit of this function as x tends to pi should be equal to f of pi, right? So let us find the limit x tends to pi of that function. Cos x by, now immediately you will realize that this is a 0 by 0 form, because 1 plus cos x is 0, cos x is minus 1, sin x is 0 when it is pi. So 0 by 0 form, I apply L'Hospital's rule, or as they say, this is a French name and has to be pronounced L'Hopital's rule. So L'Hospital's rule says differentiate the numerator, differentiate the denominator, and then apply the limit. So let us see, differentiating the numerator I get minus cos x, and then I get minus cos x minus sin x divided by plus cos x minus sin x minus sin x, yeah. Now applying the limit I get minus of minus 1 minus 0 by minus 1 minus 0, or 1 by minus 1, which is minus 1. So if f of pi is minus 1, then the function will be continuous because the limit is minus 1. Okay. Question number 16. If f of x is equal to 3x power 4 plus 4x cubed plus 12 minus 12x squared plus 12, then f of x is increasing or decreasing in which of these intervals? So let's quickly find f dash of x. F dash of x is 12x cubed plus 12x squared minus 24x, and if this is to be 0, that is, we find the points or the points where it will be extreme. What basically this gives us is x squared plus, if I take x common or 12x common, x squared plus x minus 2 is 0. Therefore, x is equal to 0 or this is equal to 0. This is nothing but x plus 2, x minus 1, which is minus 2 and 1. Therefore, we have the whole interval divided by minus 2, 0 and 1. So, there are 4 intervals. All you have to do is substitute one value in each of these intervals here and see where it is maximum or minimum. So, for the first region, second, third and the fourth. So, for the first region I choose x is minus 3. So, f dash of the first region, f dash of minus 3 would be, forget about the 12 and I just substitute here, minus 3 into 9 minus 3 minus 2 is a negative number, 4 minus 12 basically. So, here it is f dash is negative. Then in the second region choose minus 1. So, I am choosing f dash of minus 1. That would be minus 1 into 1 minus 1 minus 2. This is plus 2, which is positive. Now here I choose f is 1 by f of 1 by 2. Now 1 by 2 becomes 1 by 2 into 1 by 4 plus 1 by 2 minus 2. Even without evaluating this, I know this is a negative term, positive term. So if here it is going to be negative. That is f dash of x. I am speaking about f dash of x. And then finally here in the fourth region, let us choose x is 2. So f of f dash of 2 would be, substitute here, it is 2 times 4 plus 2 minus 2, which is positive 8, right? So here it is again positive. So in these two regions it is increasing and increasing, and in these regions it is decreasing and decreasing. So increasing in minus 2 to 0 and 2 to infinity. So increasing in minus 2 to 0, no, we have minus 2 to 0 and and 1 to infinity, not 2, 1 to infinity. So this is the correct option. Let us just see the other things. Decreasing in minus 2 to 0, it is actually increasing, so it is not true. Decreasing in minus infinity to minus 2 is true, and decreasing in 1 to infinity is false, because there it is increasing. So the only option is B. Very simple. Calculate the points where f dash becomes 0, divide it into different intervals, choose some values from each of those intervals, substitute it back into f dash of x. Wherever it is positive, increasing; wherever it is negative, the function is decreasing. Question number 17. The complete solution set of the inequality cos inverse of cos 4 is greater than or equal to 3x squared minus 4x is. Now what is cos inverse of cos 4? Now cos 4 is greater than pi, right? So it is in a third quadrant angle basically. This is third quadrant. So I need it to, and third quadrant cos is negative. This is going to be negative. So the principal argument should be in the second quadrant, right? Because cos is cos inverse of x's range is 0 to pi, and 0 to pi by 2 it is positive, pi by 2 to pi is negative. So I need an obtuse angle here. So I rewrite this as cos inverse of cos, to make it clear, 4 will be something like this. This will be the value of 4, a third quadrant angle. So I take this obtuse angle, that is 2 pi minus 4, as the principal argument. So this becomes 2 pi minus 4, right? Now substitute here. 2 pi minus 4 is greater than 3x squared minus 4x, or 3x squared minus 4x minus 2 pi minus 4 is less than 0. If it is less than 0, find the roots, and the limit is between the roots, right? And the x can be between the roots. So let us find the roots of this equation. 3x squared minus 4x minus 2 pi minus 4 is less than 0. So the roots of this equation would be 4 plus or minus square root of 16 minus 4 into 3 into 2 pi minus 4. I'm sorry, into minus of, right, by 2a is 6. So this becomes 4 plus or minus square root of 16 plus 12 pi plus 24 pi, sorry, and minus 4 into 3 into plus 4 is minus 48. So this becomes 4 plus or minus square root of 24 pi minus 32 by 6, or this is 4 plus or minus, if I take 4 common from the terms inside, I get 2 outside, and this becomes 6 pi minus 8 by 6. Cancelling 2 from the numerator and the denominator, I get the roots are this number. So x, since it is an inequality less than 0, x should be between these two roots. That is 2 minus square root of 6 pi minus 8 by 6 and 2 plus square root of 6 pi minus 8 by, this is 3. We are cancelling 2 from the numerator and the denominator. So this answer is option D, between these two roots. Okay, very simple. Just be careful about how you get the principal argument of such expressions. Question number 18. A ladder 5 meter long leans against a vertical wall. The bottom of the ladder is 3 meters from the wall. If the bottom of the ladder is pulled 1 meter farther from the wall, how much does the top of the ladder slide down the wall? So this is a very trivial question. They say a ladder 5 meter long is resting against the wall. Bottom is 3 meters. If the bottom of the ladder is pulled, so this obviously is 4, we know. This height is 4 meters, right? Now if the bottom of the ladder is pulled 1 meter farther down the wall, that is the ladder's length is the same, but this becomes 4 meters, then obviously this is going to become 3 meters. So how much does the top of the ladder slide down the wall? 1 meter. Earlier it was at 4 meters and it is going down by this 1 meter. So the answer is 1 meter. This is a very simple question. I don't know why they asked this. Maybe to test you if you still remember Pythagoras theorem. I don't know why they asked this question. Question number 19. The area bounded by the curve y is equal to half x squared. Now let's draw this quickly. Y is half x squared is going to be a parabola open upward with vertex at 0, 0, right? X axis and x is equal to 2. Okay. Now I would prefer that they specified that it is also between x is equal to 0, so that the area is definite. Otherwise it could mean any area, right? So let us take x is 0 to x is 2, and this is 1 by 2x squared. Now this also needs presents no serious trouble. The area is simply integral y dx between the limits 0 to 2. So it is integral half x squared dx from 0 to 2. This becomes x cube upon 6 from 0 to 2. So this is 8 by 6 or 4 by 3. So the answer is 4 by 3 square units, 19D. Let us move on to question number 20. If 1 plus x minus 2x the whole square, 2x squared the whole raised to 6 is 1 plus a1x plus a2x squared plus a3x cubed plus a4x power 4 up to a12x power 12. Then the value of a2 plus a4 plus and so on up to a power 12 is. Now please don't think that this is a binomial. This is based on ideas from binomial theorem, but not a problem where you are trying to expand the whole thing using binomial theorem and then finding the coefficients and then adding it. It's nothing of that kind. See, all we need is even coefficients, right? So somehow we have to eliminate the odd coefficients from this. All this technique is based on substituting x is 1 and x is minus 1 and then subtracting the two equations. What do I mean? If I take x is equal to 1 in this equation, this becomes 1 plus 1 minus 2 into 1 squared. The whole part 6 is 1 plus a1 into 1. plus a2 into 1 squared plus a3 into 1 cube plus and so on up to a11 into 1 power 11 a12, right? Now if I take, so this left hand side is 0 basically, so 0 is 1 plus a1 plus a2 up to a11 plus a12. Now if I take x is minus 1, this becomes 1 minus 1 minus 2 into 1 the whole power 6, and the right hand side will become 1 minus a1 because a1 into minus 1 but plus a2 minus a3 and so on. All the odd power terms will be minus and even power terms will be plus. So what will be the value of this? 1 minus 1 minus 2 is minus 2. Minus 2 raised to 6 is 32. So add these two, you get 32 is equal to 1 plus 1 2, and all the odd powers will get, odd terms will get cancelled. So you'll have a2, a4 up to a12, but remember all those will be represented twice. There's an a2 here and an a2 here. So I'm sorry, x2 raised to 6, silly mistake here, 2 raised to 6 is nothing but 64. Okay, so if I bring this 2 here, 62 divided by 2 is 31, is a2 plus a4 up to a12. So the answer is 31, option A. Okay. Okay. Now we begin the subjective numerical part. So the first question is this: limit x tends to 2, 3 to the power x plus 3 to the power 3 minus x minus 12 by 3 to the power minus x by 2 minus 3 to the power minus 1 minus x is equal to. Now, of course, this problem you can do directly using L'Hospital's rule, differentiate and all, using one simple expression. D by dx of a to the power x is a to the power x log a. You can do it using this. Let us go ahead with another technique. I'm going to take I'm going to make a substitution. Y is 3 to the power x by 2. Okay, and that will help making all these terms in terms of y and 2, y squared and all of that. Okay, so let us see what will 3 to the power x be. It is 3 to the power x by 2 the whole square, so it is y squared. So the first term is y squared. Then 3 to the power 3 minus x can be written as 3 cube by 3 power x, which is 27 by, 3 power x is y squared, so y squared. Then 3 to the power minus x by 2 is 1 by 3 to the power x by 2, which is 1 by y. And 3 to the power 1 minus x is nothing but 1 by 3 to the power, 3 power 1 by 3 to the power x, which is 1 by 3 power x is y squared. 3 by 3 by y squared. So the whole thing can become limit x tends to 2, of course. When x tends to 2, y tends to 3 raised to 2 by 2, which is 3. So y tends to 2. 3 power x we have y squared plus 27 by y squared minus 12 divided by 1 by y minus 3 by y squared. Okay, so let us simplify these terms a little more. So this becomes y to the power 4 plus 27 minus 12 y squared by the y squared and the y squared of the LCM here I am going to cancel. So this becomes y minus 3 by y squared. Makes sense? This is 1 by y and this is minus 3 by y squared. Now if I do substitute x is, y is 2 here, what would I get? 2 to the power 4 is 16. Sorry, y tends to 3 I said. Okay. Okay. In which case we can see that this is going to become this is basically a 0 by 0 form. If you substitute 3 here, and you can check for yourself, it is 0 by 0. How to resolve this? L'Hospital's rule, L'Hopital's rule. So if I differentiate this, I get 4y cube minus 24y. This becomes 1. Now substituting 3, it is 4 into 27 minus 24 into 3, which is 108 minus 72 or 36. So the limit is 36. The answer to this question, 36. Just for the sake of completeness, let me show you how to do it the other way also. That is basically 3 to the power x plus 3 to the power x, 3 minus x minus 12 divided by 3 to the power minus x by 2 minus 3 to the power 1 minus x. So remember, basically if I go straight ahead with L'Hospital's rule, 3 to the power x when differentiated becomes 3 to the power x log 3. Now this function becomes 3 to the power 3 minus x log 3, and then a minus 1 when I differentiate 3 minus x. 12 is gone. This term becomes 3 to the power minus x by 2 log 3 into minus 1 by 2. This becomes 3 to the power 1 minus x log 3 into minus 1. So the log 3 can be dropped from everything, and then substitute x is 2. I get 3 squared 9 plus 3 to the power 3 minus 2, which is 3 with minus, so it is minus 3. So 9 minus 3, right? Okay, by here it becomes 3 raised to minus 1, so 1 by 3 into minus 1 by 2, so minus 1 by 6, and finally I have here 3 raised to minus 1 is 1 by 3, so becomes plus 1 by 3. So this is 6 by 1 by 6, which is 36. So this also yields the same, but be careful about the differentiation of 3 to the power x terms. Let us move on to question number 22. Consider a family of circles passing through two fixed points 3, 7 and 6, 5. The chord in which the circle, another circle is given. There is a family of circles like this, and another circle x squared plus y squared minus 4x minus 6y minus 3 is equal to 0 cuts each member of the family of circles, passes through a fixed point a comma b. Then the value of a plus 3b is a bit intricate problem. See, let us call this family of circles as C1 and let this circle be C2. So C1 can be any circle which passes through these 2 points. Okay, I'll tell you why I draw this line. So let us say this is C1, any circle like this, and there is another circle C2. Sorry, it is more like a potato and not a circle. C2, and the chord in which this is the chord where these two circles intersect. Now this chord, they say, passes through a point a comma b, and then the value of this a plus 3b is. So there are a lot of tasks here. First, find the general equation of this family of circles, and then define the chord of intersection. Okay. Now, if they are given 2 points, how do you find a circle through 2 points? We know that any family of circle through these 2 points can be written as the circle passing through those 2 points as the diameter plus the line, which is the diameter, equation of the diameter itself. So the circle with these 2 points as the diameter plus the line which passes through these 2 points, a linear combination of this will give any circle which passes through these 2 points. Therefore, C1 will be of this form. So let's calculate C, that is a circle whose ends of the diameter are 3, 7 and 6 minus 6, 5. We know that the equation for such circles is x minus x1 and x minus x2 plus y minus y1 into y minus y2 is 0. Yeah, okay. So x minus 3 into x minus 6 plus y minus 7 into y minus 5 is 0. Expand this quickly. It is x squared minus 9x plus 18 plus y squared minus 12y plus 35 is 0, or x squared plus y squared minus 9x minus 12y plus 53 is 0. This is C. Then let us find L. L is nothing but the straight line passing these 2 points. So x minus 3 by 6 minus 3 is y minus 7 by 5 minus 7. So this becomes minus 2x plus 6 is 3y minus 21, or 2x plus 3y minus 27 equals 0. So this is the equation of the circle, and this is the equation of the line. Therefore C1, the family of circles, is nothing but x squared plus y squared minus 9x minus 12y plus 53 plus lambda times 2x plus 3y minus 27 equals 0. And C2, let us just write it down here, is x squared plus y squared minus 4x minus 6y minus 3 is equal to 0. Now to find the chord which cuts these two, we have to find the points which are common to these two circles, right? So if both are supposed to be simultaneously 0, I am just going to subtract these two equations, and that will give me the equation of one straight line, and that will be the equation of the line which is the chord of contact, right? Whenever they give you two circles, to find the chord at which they intersect, you just subtract the two circles. I am going to subtract C1 and C2. What would I get? X squared and y squared will be gone. Here I will get minus 5x, minus 6x and 56. So let me write it down. Minus 5x, minus 6y plus 56 plus lambda times the other equation. The other equation is 2x plus 3y minus 27. 2x plus 3y minus 27 is equal to 0. Now this is the family of the chords of intersection of any circle there and this circle, right? Because they have said C1 is a family of circles and C2 is just one single circle. So you can get different chords. All these chords are represented by this equation with one parameter lambda. Now we know that all these lines will pass through one particular point, definitely, which is the point of intersection of this and this. Correct? Therefore, that point A comma B through which this chord that fixed point A comma B through which this chord passes should be the point of intersection. So if I find the point of intersection of these two, I just have to solve the two equations. 5x plus 6y is 56 and 2x plus 3y is 27. So let us call this 1 and 2. 1 minus 2 times 2 would give me 5x plus 6y is 56 minus 4x minus 6y is 54. Minus 54. Therefore, it will become x is 2. And substituting x is 2 here, I get 2 into 2 plus 3 into y is 27, or y is 27 minus 4 upon 3, 23 upon 3. So the A comma B is nothing but this point of intersection 2 and 23 comma 3. Excuse me. Now the final question is A plus 3B. So how much would A plus 3B be? This is 2 plus 3 into 23 by 3, which is 25. So the answer to this problem is 25. Okay. Find the family of circles using this circle as a diameter, these 2 points as the diameter of the circle, and find the equation of straight line. So that gives the family of the circles. And then there is the other circle which intersects this family of circles. To find the chord of intersection, subtract these two circles. Now if this is to pass through one fixed point, we know that one fixed point is going to be the intersection of this line and this line. That is what we have solved. A and B gives A plus 3B. 23. P is a point on the parabola whose ordinate equals its abscissa. Ordinate means the y coordinate and abscissa means the x coordinate. A normal is drawn to the parabola at P to meet it again at Q. If S is the focus of the parabola, then the product of the slopes of SP and SQ is. This is a simple problem, although it may be a bit lengthy. Let us take the standard parabola. You can take any parabola. Y squared is 4ax, right? Now they said that there is a particular point on the parabola P, okay? Now this point P, the ordinate equals its abscissa, that is x is going to be equal to y. Which is that point? Now we'll take, if x is equal to y squared is 4ay. This would give me y is either 0 or y is 4a. We'll take the non-trivial value 4a. If y is 4a, I substitute that here, I get x is also equal to 4a. So this point, this implies x is 4a. Okay. So this point is 4a, 4a. Now what are they doing? A normal is drawn to the parabola at P. So they draw a normal at P. And this meets the parabola again at Q. So Q is here. Let us find where this Q is. So first find the equation of the normal. So first we get the equation of the slope of the tangent. From that we get the slope of the normal. So our aim is normal at P. Now what is the slope of the tangent? Slope of the tangent is dy by dx. So if y squared is 4ax, 2y dy by dx is 4a, or dy by dx is nothing but 4a by 2y, 2a by y. At x comma y is equal to 4a comma 4a, dy by dx is going to be a nice round number 2a by 4a, which is 1 upon 2. Okay, so the equation of the the slope of the tangent is 1 by 2. So we know slope of the normal is the reciprocal and the negative, minus 2. Therefore the equation of a line passing through 4 comma 4a and minus 2 is going to be y minus 4a is minus 2 times x minus 4a. Now if I simplify this a little, I get 2x plus y and plus 8a when it comes to this side becomes minus 12a is 0. So this is the equation of this line, 2x plus y minus 12a is 0. Now if this line intersects the parabola again at another point, so how to find that point? Solve this and the parabola. How can I do that quickly? Find the value of x and substitute it there. This gives me x is 12a minus y upon 2. Substitute this in y square is equal to 4ax. So y squared is 4ax and x I found as 12a minus y by 2. So this becomes 2a. So y squared is 24a squared minus 2ay, or y squared plus 2ay minus 24a squared is 0. So the solution would be y minus 4a and y plus 6a is 0. We get the roots as y is 4a and minus 6a. Now y is 4a is already the point that we considered as P. So y is minus 6a must be the case. So if y is minus 6a, y squared is 4ax implies that 36a squared is 4ax, or x is 9a. So the other point is 9a comma minus 6a. This is Q. Let's go back to the previous slide one moment. So this point is 9a comma minus 6a. Then let's continue. S is the focus of the parabola. So S is somewhere here and the focus is a comma 0 we know. Now the product of the slopes of SP and SQ is what? Okay. Now SP, S we know is 0 comma a comma 0. P is 4a comma 4a. Q is 9a comma minus 6a. So the slope of SP is nothing but this is a comma 0. Remember, a comma 0. So 4a minus 0 by 4a minus a, which is 4 by 3. Slope of SQ is minus 6a minus 4a, minus 6a minus 0 by 9a minus a, which is minus 6 by 8 or minus 3 by 4. So the product of the slopes, slope of SP into slope of SQ is going to be 4 by 3 into minus 3 by 4, which is 1, minus 1. So the two lines are actually perpendicular. So the answer to this problem is minus 1. Okay, a bit lengthy, but based on very simple ideas. Find the slope of the tangent, find the equation of the normal, find where it intersects again, and then find the two slopes and multiply them. Let us go to the last but one question. Z is 1 by 2 root of 3 minus I and the least positive integral value of n such that this expression is k, then the value of 2 by 5 of k. 2 by 5 of k is 2 by 5 of n basically. Okay, so let us see. Let us focus on z. If I take z is 1 by 2 into, in front of root 3 I add a minus I squared because minus I squared is plus 1. So if I take an I out, this becomes minus I root 3 minus 1, or this is I into minus 1 by 2 minus I root 3 by 2. If you remember, this is nothing but omega squared because omega is minus 1 by 2 plus I root 3 by 2. Omega squared is minus 1 by 2 minus I root 3 by 2. Alright. So now let us simplify this expression. Let us do z power 101 plus I to the power 109, the whole power 106. Now z power 101 is going to be I omega square power 101 plus I power 109. Now this is I power 101 omega power 202 plus I to the power 109 106. Now remember, I goes in parts of 4, omega goes in parts of 3, right? So I to the power 101, 100 is a multiple of 4, so this is just I. 201 is a multiple of 3, so I'll get only omega. The same way 109, 108 is a multiple of 4, so I get just I power 106. So if I take I common, I get this and becomes like this. Now what is 1 plus omega squared? 1 plus omega is minus omega squared because 1 plus omega squared is 0. So 1 plus omega is minus omega squared. So this becomes I power 106 is I squared because 104 is a multiple of 4 and this is omega power 212. Now in this again, this is minus and minus 1, I squared is minus 1. 210 is a multiple of 3 and the remainder is 2. So it's minus omega squared. Okay. So what we have is the left hand side is minus omega squared, the right hand side is z power n. So z power n is minus omega squared. Now z is, we know, I omega squared power n is minus omega squared. So this should be I power n omega power 2n is equal to minus omega squared. If I bring the omega squared to this side, I get I to the power n omega to the power 2n minus 2 should be minus 1. Okay. This is possible only because omega can only be 1. This can be minus 1. Okay. So let us write this once more here in the next page. I to the power n omega power 2n minus 2 is minus 1. So this can happen when omega power 2n minus 2 is 1 and I to the power n is minus 1. Now for this to happen, 2n minus 2 should be a multiple of 3, right? So it has to be 3, 6, 9, 12, etc. Only then this can happen. So in these various cases, what will be the value of n? If 2n minus 2 is 3, n will be 5 by 2 or 4 or it will be 11 by 2 or 6 or 7, 7. and then so on, right? So basically you see the integer values will be 4, 7, and the next one will be 10. So n can be 4, 7, 10 and so on. Now here I to the power n is equal to minus 1 means the n should be of the form 4k plus 2, right? Because 4k will become 1 and plus 2 makes I squared, which is minus 1. Therefore n can be 2, or it can be 6, or it can be 10. When it is 2 it is 10, 14 and so on. So the least value in both will be n is 10. So n is 10 will satisfy this condition. Okay, you can check manually here. So if n is 10, then they have asked us 2 by 5 of n, because n is k they said. So 2 by 5 of n would be 4. So the answer is 4, plain number 4. Very simple, but identifying this I omega square is key. The last question. The angle between the pair of tangents drawn to the ellipse, there is a certain ellipse, and there is a point 1, 2. So from here they have drawn a pair of tangents to this ellipse. Now the angle between the pair of tangents is what? Okay. Now this is quite easy if we remember what is the expression for the pair of tangents from any external point to an ellipse, right? How do we do that? Take S to be the equation of the ellipse. Okay. And S1 as substituting this point given in this, that is S1 would be 3 plus 12 minus 5, 3 plus 8 minus 5, which is 6. Then also the tangent to this is of the form 3x x1 plus 2y y1 minus 5 is 0. If you put 1, 2 here, it becomes 3x plus 4y minus 5 is 0. So using this S1 and T, the pair of tangents as a pair of straight lines is given by S1 is T squared. Okay. So SS1 is 3x squared plus 2y squared minus 5 into 6 is equal to 3x plus 4y minus 5 the whole squared. So 18x squared, 2 plus 12y squared minus 30 is 9x squared plus 16y squared plus 25. Then plus 24xy minus 30x minus 40y. Okay. Now I'm bringing all to one side. I get 9x squared minus 24xy minus 4y squared plus 30x plus 30x plus 40y minus 55 is 0. Now this is the pair of tangents. Okay. Now this is represented in a pair of straight lines form. Now in a pair of straight lines form, that is, if I have ax squared plus 2hxy plus by squared plus 2gx plus 2fy plus c is 0, the angle between the lines is given by tan theta as mod of 2 square root of h square minus ab by a plus b. Now in our equation, a is 9, right? 2h is 24 and minus 24, and y and b is minus 4. So h is minus 12 and b is minus 4. Substituting this here, theta is tan inverse of 2 times square root of 144 minus 36 by 5. So this becomes theta is tan inverse of 2 into square root of 180 by 5, or tan inverse of 2 into 6 root 5 by 5, which is tan inverse of 12 by root 5. Of course the modulus is still there. Now you compare this with the given question. They have given that the angle is tan inverse of 12 by root lambda. So in the place of root lambda, you have root 5. So lambda is 5. Therefore, the answer to this problem is 5. That brings us to the conclusion of the NTA's mathematics test paper number 4. See you again with NTA test paper number 5. This is SANTOSHSIR from Parth Tank Mathematics Institute, Ahmedabad.